Hello, chemistry students. This is Dr. Baxley. In this video, I'm going to give you some hints for how to learn the polyatomic ions. When you look at the list of polyatomic ions, it might look like it's pretty random. There are all these different symbols with different charges and different names, and it might be really hard to memorize them because it looks so random. However, it turns out that there are some patterns in the naming system, and if you know these patterns, that will help you learn names and the formulas of the ions more quickly. For this video, I have broken up the types of ions into different categories. So the first type are going to be the most common ions. These are going to be ones that you're going to see quite often, and there isn't really much of a pattern to them, but you're just going to have to memorize these. Okay, so here are those three most common ions. The first one is ammonium. Notice that ammonium has a positive charge. Ammonium is the only polyatomic ion that you need to learn that has a positive charge. So hopefully that will help you remember it because it stands out from the other ones. One thing that you should know about ammonium is that there is a related molecular compound named ammonia. Ammonia, as I said, is a molecular compound, and its formula is NH3. Notice that it doesn't have a charge. This is because it's a molecular compound, whereas ammonium is a polyatomic ion. Notice that the difference in the names of ammonium and ammonia is just in the last couple of letters. So ammonium ends in IUM, whereas ammonia ends in IA. For this class and for your general chemistry class, you should know the difference between ammonium, which is NH4 with a positive 1 charge, and ammonia, which is NH3 and is a neutral molecule. The next of the most common ions is hydroxide. Hydroxide is interesting because this is what makes solutions basic if they are basic. It's because they have hydroxide in them. Hydroxide is also interesting because it ends in the letters IDE. Usually when an anion ends in the letters IDE, that means it's a monatomic ion. A monatomic ion is an ion such as chloride that only has one element in it, as opposed to these polyatomic ions that have more than one element in them. So usually when you see this IDE ending, it means that it's a monatomic ion. There are two exceptions to that. One is hydroxide, as you see here, and another one is cyanide, which we'll see later. So hydroxide is OH minus 1. This is another one that you just need to memorize. The last of these most common polyatomic ions is the acetate ion. In a way, acetate ion is one of the most complicated of the polyatomic ions that you need to learn because it has 3 elements instead of just 2. One thing that makes it easier is that it is pretty common, so you will see it often, and that will help you memorize it. To help you memorize acetate, it is helpful to remember this pattern of 2, 3, 2 that you see in the formula of the polyatomic ion. So try to remember that acetate has CHO for carbon, hydrogen, oxygen, and that the pattern is 2, 3, 2. And remember that acetate has a -1 charge. This should help you. Okay, so those are the most common ions. The next type of polyatomic ions in my grouping are those that ends in 8. Now, acetate also ends in 8, but it doesn't quite fit the pattern of these ions that end in 8. Let's look at the relationship between the formulas of these polyatomic ions and where the other element, other than oxygen, fits in the periodic table. The first one we're going to look at is the one with nitrogen. So that one would be called nitrate. Notice that nitrate has 3 oxygens, and overall the charge on the polyatomic ion is -1. Okay, before we move on to the next ion, you should be keeping a list in your notes of the formulas and names of these polyatomic ions. So if you haven't done so yet, write NO3- and nitrate in your notes. All right, now that you have that in your notes, let's look at the next polyatomic ion that ends in 8. and we're going to look at the one containing carbon because carbon is right next to nitrogen in the periodic table. The formula for carbonate is CO3 with a 2- charge. Go ahead and write that down in your notes. Now that you have carbonate written down, notice the pattern between these two polyatomic ions. They both have the same number of oxygens, 3 oxygens, but their charge is different by 1. Nitrate has a -1 charge and carbonate has a -2 charge. So notice that in the periodic table, the polyatomic ion that is further to the left tends to have a lower charge by 1. Let's look at how that pattern continues in the next period down in the periodic table. So let's look at the polyatomic ion containing sulfur. This one would be called sulfate. Let's look at its formula. Here it is, SO4 with a 2- charge. So take the moment to write down SO4 2- sulfate in your notes. Notice that sulfate, being down 1 lower in the periodic table than nitrate and carbonate, has 1 more oxygen in it. Let's look at how this pattern continues when we look at the polyatomic ion that contains phosphorus that ends in 8. So that would be called phosphate. So based on the pattern that we saw above, we should expect that there would be the same number of oxygens, but the charge would be 1 lower. And it turns out that that pattern does continue. Here's phosphate. So take a moment to write down PO4 3- and phosphate in your notes. Okay, now that you have written down PO4 3- and phosphate, notice that phosphate and sulfate both have 4 oxygens and they both have, or their charge differs by 1. Sulfate is -2 and phosphate is -3. Phosphate is a little bit tricky because it is the only polyatomic ion that you need to know that has a 3- charge. All of the other ones have either a 1- charge or a 2- charge. So remember that phosphate is unique. It's very important that you remember this because this will affect how you put it together with other elements when you make compounds. Okay, now we're going to look at the last 3 of these polyatomic ions that end in ATE. And these ones contain chlorine, bromine, and iodine. Now the pattern does not continue for sulfate and chlorate. They do not have the same number of oxygens. Chlorate actually has 1 fewer oxygen than sulfate. Now that might be confusing, but it's just another one of those quirks that you're going to have to remember. There is a polyatomic ion that has chlorine with 4 oxygens in it and a -1 charge, but that one isn't named chlorate. We're going to learn it in a later group. Okay, so chlorate is ClO3 with a -1 charge. Go ahead and write that in your notes. Now we're going to see how the pattern continues as we go down the row from chlorine to bromine to iodine. So let's look at bromate. So bromate still has the same number of oxygens as chlorate and it has the same charge. So that helps to make things a little bit easier to remember these guys. So write down BrO3- bromate in your notes. As you're writing down these polyatomic ions, I hope that you are noticing that the number of oxygens is subscript and the charge is a superscript. It's very important that you write these polyatomic ions down with the correct notation. So always put the number of oxygens as a subscript and then the charge as a superscript. Okay, let's continue looking at this pattern. So we've looked at chlorate and bromate, and we see that they have the same number of oxygens and the same charge. Well, fortunately, iodine follows the same pattern. Iodate also has 3 oxygens and a -1 charge. Take the time to write that in your notes. So now we see a list of how many? 7 polyatomic ions that all end in 8. And you don't need to memorize that these patterns exist. I'm only giving you these patterns so that they will help you to memorize these polyatomic ions much more quickly. Okay, let's look at the next group of polyatomic ions. These ones end in ite, I-T-E. I have listed here the polyatomic ions ending in ate that you just learned. Now there's a pattern between when an ion ends in ate and when it ends in ite. Let's look at the first one, nitrate. Now let's look at the formula for nitrite. So nitrite has one fewer oxygen than nitrate, but it has the same charge. Go ahead and take the time to write this into your notes. One way that I remember this is just from a silly little thing that a student told me once, which is, ick, I ate too much. And it's telling you that if I ate too much, I had more oxygens than if I ate less. I know it's silly, and maybe you have a different way of learning it, and if so, you can post that in Piazza and share it with the other students. All right, so nitrite has one fewer oxygen than nitrate. It turns out that there is not a carbonite ion, so we're going to switch now to sulfite. So sulfate is SO4 with a 2- charge. Sulfite has one fewer oxygen, but the same charge. So here it is, sulfite. Okay, so notice that sulfite has one fewer oxygen and a 2- charge. Take the time to write that in your notes. Okay, now we're also going to skip phosphite and we're going to move on to chlorite. So based on the pattern that we've seen so far, I think you might be able to figure out that chlorite is ClO2 with a -1 charge. And go ahead and write that in your notes. Now that you've written chlorite in your notes, can you figure out the pattern to see what bromite and iodite are? Hopefully you came up with that they both have 2 oxygens and a -1 charge. So go ahead and write bromite and iodite in your notes. Okay, so now we have seen a set of polyatomic ions that end in ATE and a set of polyatomic ions that end in ITE. And the way to remember which one's which is that ite ends in fewer oxygens and ate has more oxygens. The unfortunate part of this is you do have to remember how many oxygens they each have, but you can remember that one has more and one has fewer. Okay, things are about to get more complicated because there are also polyatomic ions that start with per or hypo. So I have listed here the polyatomic ions with chlorine, bromine, and iodine. So you might notice that we've whittled down the number of polyatomic ions. We're no longer looking at polyatomic ions containing sulfur, phosphorus, nitrogen, or carbon. We're just going to look at these 3 elements. And for these 3 elements, they're the only ones that follow this pattern that we're going to learn for per and hypo. Okay, so let's take the ite ions, the one with 2 oxygens, and take away 1 more oxygen. So how are we going to say that there's even 1 fewer oxygen than the number of oxygens that ite has? Well, what we do is we put in the prefix hypo. So you can remember this because it's sort of like a hypodermic needle. So hypodermic needle is one that goes under your skin. So hypo means under. So hypochlorite has 1 fewer oxygen than chlorite. Okay, so do you see the pattern? Starting on the right with chlorate has more oxygens. Chlorite has 1 fewer oxygen. Then hypochlorite has even 1 fewer oxygen than chlorite. I know this is confusing, but it is helpful that there is a pattern. It's also helpful that they all have the same charge. This pattern continues for bromite. If you take away 1 more oxygen, it becomes hypobromite. And for iodite, if you take away 1 more oxygen, it becomes hypoiodite. Hopefully you've had a chance to write this in your notes. The pattern continues. You can also add one more oxygen to each of these. So how are we going to denote that we've added even one more oxygen than chlorate? If 8 means that I have more oxygens, how can I say I have even more oxygens? You might think that you might say hyper, because that's the opposite of hypo. Like if a kid is hyperactive, they're extra active. They have extra activity to them. So we could call it a hyperchlorite. However, for some reason, we don't call it that. Instead, we keep off the HY at the beginning and we just call it per. Instead of calling it hyperchlorate, we call it just perchlorate. So if you add one more oxygen than chlorate, then you get perchlorate. And if you add one more oxygen than bromate, then you get perbromate. And if you add one more oxygen than iodate, you get periodate. Okay, we have another group to learn about, and those are ones that begin with the prefix bi or thio. So we've already learned about carbonate and sulfate. So let's look at carbonate, and now let's add an H to it. Not just an H, but an H with a positive charge. If you add an H with a positive charge, you're going to change the charge on the polyatomic ion. Instead of being a 2- charge, it's now going to be a 1- charge. One common way to name this would be to call it hydrogen carbonate. And there's nothing wrong with naming it that way. And in fact, some people will name it that way. However, it's not the most common way to name it, and it's not what I usually call it. So it's really useful to know what most people, including your chemistry teacher, are going to call it. And that is bicarbonate. So if you see that prefix bi, that means that you've added a hydrogen plus ion to your polyatomic ion. So now it has a less negative charge and it has a hydrogen in it. Of all the polyatomic ions that you need to learn, the only one that you need to learn that begins with bi is bicarbonate. So that's useful. Okay, now let's look at the sulfate ion. And what we're going to do with the sulfate ion, we're not going to add an H plus to it. Instead, we're going to turn one of the oxygens into a sulfur, but keep the charge the same. Okay, so if we turn an oxygen into a sulfur, that means we're going to have one fewer oxygen, so we'll have 3 oxygens, and one more sulfur, so we'll have 2 sulfurs. So here it is, S2O3-. Notice that it's very similar to sulfate, except that an oxygen has been turned into a sulfur. And you're able to do this because sulfur is right below oxygen in the periodic table, so they have some common properties. If you turn an oxygen into a sulfur, you put the prefix thio in front. So thiosulfate is just like sulfate, except one of the oxygens has been turned into a sulfur. We're going to see this pattern later on a later slide. So remember this prefix of thio, meaning that an oxygen atom has turned into a sulfur atom, but the charge stays the same. Okay, let's look at the next grouping of ions, group 6. These are ions related to cyanide. So here's cyanide, Cn with a -1 charge. Cyanide is the other polyatomic ion that you need to learn that ends in IDE. Remember we talked before about how usually an ion that ends in IDE means that it's a monatomic ion with just one element, except for 2 exceptions, and those are hydroxide, OH-1, and cyanide, Cn-1. I usually find that students remember cyanide pretty easily because, well, you know that it's a poison, and that helps it stick out. Okay, what we're going to do now is we're going to add an oxygen to it. So, what do you name something when you've added an oxygen to it? Well, you change its ending to ATE. That means I've added an oxygen. So this ion is called the cyanate ion. Okay, so cyanate is sort of like cyanide, only it has an extra oxygen on it. Notice that this doesn't change the charge. Now, what would we call it if we turned that oxygen into a sulfur? Unfortunately, when we do that, the sulfur gets put in front of the polyatomic ion instead of in the back. And there is a reason for that, and that is because sulfur is lower in the periodic table, and so it's closer to metals. That's not something you really need to know, but it is helpful to learn that things that are closer to metals tend to be earlier in the formula of a polyatomic ion. Okay, so now we've turned an oxygen into a sulfur. What do we do with that? Do you remember that from the previous slide? We put on the prefix thio. So this is going to be called thiocyanate. So it's cyanate, which used to have an oxygen in it, but we turned that oxygen into a sulfur. So now it's thiocyanate. Okay, so this is getting pretty esoteric, I understand, but I'm really hoping that these patterns of seeing where these names came from will help you to memorize these polyatomic ions. Okay, there's only one last group of polyatomic ions, and I'm afraid that for these ones, there really isn't much of a pattern. You really just have to memorize them. The first one is oxalate, which is C2O4 2-. The next one is permanganate, which is MnO4 -1. Notice that in MnO4, the M is capitalized and the N is lowercased. It is extremely important when you're writing formulas for any sort of a compound or a polyatomic ion or even just an element that you get the capitalization right. In an element, the first letter is always capitalized. If there's only one letter, such as carbon, then it's just capitalized. But if you have two letters in the symbol for the element, such as manganese, Mn, then the first one is always capitalized and the second one is always lowercase. It's really, really important that when you're writing chemistry symbols that you use those symbols correctly, because that means something to a chemist. And you're learning how to be chemists, so you have to write those symbols correctly. So Mn with a capital M and a lowercase n is the manganese element, and MnO4- is the permanganate ion. The next polyatomic ion is chromate. So chromium is capital C, lowercase r, and the chromate ion is CrO4 2-. Finally, the last polyatomic ion that you're going to have to learn for this class is dichromate. So the di here does in fact mean 2. It means you have 2 chromium atoms. However, notice that that also changes the number of oxygen atoms from 4 to 7. So the dichromate ion has 2 chromiums and 7 oxygens, but it still has a 2- charge. There's a little bit of a pattern here, but it's still pretty much something you have to memorize. Okay, on my last slide, I have all of the polyatomic ions that we have gone over in this video. Notice that I have them broken up into groups of polyatomic ions. Grouping the polyatomic ions in this way should help you to see patterns, which will help you memorize the polyatomic ions faster. Making flashcards and using those flashcards often is also extremely important. Notice that the slight difference in a name can mean a really big difference in the formula, such as nitrate and nitrite. The difference in one letter, an A to an I, makes the difference between 3 oxygens and 2 oxygens. And this is really important because in chemical reactions, nitrate behaves differently from nitrite. So it's very important that you get these really subtle differences down. All right, so make your flashcards, start using them, and learn these polyatomic ions really as soon as you can. I hope that you found this video helpful, and if you have any other hints for remembering any of these, go ahead and post them on Piazza and share them with the class. Have a great day.